Hello and welcome back to the show. My name's Relva. This is Do All the Things, yada yada yada. On today's episode, I am switching up the foot switching in Project Jubilee. If you've been following the comedy, you know that I built a Marshall Jubilee into an old trainer Voice Master, and it works really well and sounds so good. Does it sound a lot like the original Jubilee? I have no clue. I've never heard an original Jubilee in my life, though it is putting out to such a capacity where this is what I imagine what the Jubilee probably sounds like. Like the sound that's coming out of this makes sense, and it's been a bit of an evolution. When I first plugged it in, it didn't work. I made a couple stupid mistakes. It's very complicated what's going on in here. Well, it's really not that complicated. It's just there's a lot to follow, and I designed this map myself. Had to correct some mistakes on the go. Once I got it running, it didn't sound like a Jubilee, half because I was using repurposed parts, scrapped parts out of other old amps. So in another phase of evolution, probably the last video I posted about this amp, I fixed all that. I put all fresh pots, all fresh components where I thought the components were sketchy, and boom, came to life. No problem. This amp sounds awesome now. Now, right now, my foot switching circuit is this little convoluted contraption we got going on here, where we have our relay, then we have a buffer cap and a flywheel diode, and then over here, just kind of hanging off, that's a transistor, a 4401 NPN. And basically what it's doing is it's detecting any contact to ground via the foot switch, and then that's using that to trigger and fire the relay. It works because of our center tap has 3-volt potential to the heater rails. So it detects that little 3-volt DC source, that little 3 volts coming off the chassis when you ground out the foot switch, and then boom, trigger. The only thing is, it's kind of a temporary rig. It was also a proof of concept that I could use transistor buffering, and I had this whole big plan of using all sorts of transistor buffering. But, you know, I've decided to take a more straightforward approach a lot more similar to what the Jubilee would actually use, just, you know, with my own little twist on it. Now, one of the biggest problems with the Jubilee is that you cannot foot switch the rhythm clip, and I believe that should be foot switchable because it can give you certain layers of tone, especially since I don't know if this is a flaw with my amp or if the Jubilee does this too, but if the rhythm clip is turned on or off, it affects the tone on the lead channel, which does make sense to a point if we look at the schematic. The lead circuit is coming off VR2 here and going into this buffer stage, but the rhythm section is it's bypassing this gain stage, and it's flowing down here, and then it takes 2 paths this way to the buffer stage, and or if rhythm clip is on, this way to the buffer stage. Now you're going to notice that right here we have a ground point, and this switch basically grounds out whatever channel you're not using at the time. Now what happens is when you're using the lead channel, there is ground reference going like this. But if this switch here, the rhythm clip switch, is open, then, well, we have a 47K resistor here, and then a 2.2N capacitor here, also with ground reference. So when that switch is off, there seems to be a bit of mid boost in the tone. This little stack here attaching to ground is similar to a tone circuit. It makes complete sense that it would affect the tone, having that hanging off the bottom of the lead circuit. So what happens is, when we flick this switch on, we have ground reference go this way. And then because both sides of this capacitor are now grounded, the sound changes. I find it has a flatter, more even sound with the rhythm clip on, but then there's this mid boost with the rhythm clip off, and that could be handy. I don't overall like the sound of that mid boost while I'm just riffing out, but you know, it could be a nice little punch if you're going into a solo or something, or just want to switch up the tone a little bit. However, what if you were in a playing condition which you weren't using the rhythm clip, and you say wanted to switch back and forth between lead and clean? Well, you would have to have the rhythm clip button turned off, and then you would have to deal with having that mid boost unless you're willing to go over to the amp and start pressing on buttons, which we don't want to do. Also, when the amp's turned up, you have more options. You've got your lead, your rhythm, and your clean. You can switch between all three of them while you're playing. Now, because of how the gain structure on this amp works with the various implements of volume knobs, you would get a huge volume boost if you were dialed in for rhythm and then switch to clean. But that is compensated by if you switch to a pickup that's less hot on your guitar and actually sounds good clean, it kind of works itself out. So either way, I want to be able to switch all this. So the circuit I've devised is actually really friggin' simple. We have our heater connections here, and then we have ourselves a rectifier bridge with our, obligatory. As a result, we end up with a positive and a negative. Then whatever, a filter cap there. In this particular circuit, it's 1200 UF because that seemed to be what the math told me would be good. Now, as it stands right now, between these 2 points, we have 6 volts. However, coming off the center point here to chassis ground is 3 volt potential. So if we connect this guy to ground, we get 3 volts negative, and or this guy to ground, we're going to get 3 volts positive. We can use that to our advantage. Now, the way the circuit is devised, we want to ground out our foot switch so that our foot switch has the same ground, 0 potential to chassis. So if something goes wrong, your foot switch can't get electrified. It's safe and protected to yada, yada, yada. Most amps do it that way. The Jubilee does not. The Jubilee actually has what appears to be an isolated foot switch so that it can share connection to the heaters. That's easy enough to do if I put an isolated jacket here, but this is more fun. So how it's simply going to work is, we say take some 3 volts off the 3 volt DC rail. We connect that to a relay coil. And then as soon as, through the process of the foot switch, we connect this to ground, it's going to fire, assuming this is a 3 volt relay. And that's exactly what we have. There is one other little provision in that we need a capacitor, because this side of the rail is going to be filtered, but this side isn't. So if you just directly connect this relay to the ground, it's going to buzz. It's only getting halfway rectified. This little capacitor, which in our case is going to be a 220U, is going to smooth that out and make the capacitor fire reliably. Now, the capacitor value is semi-important. It has to be big enough to have a reliable fire, but small enough that it doesn't affect the circuit. If your capacitor is too big, there's going to be a delay time turning on and off. A delay turning on as the capacitor charges up, which is semi-imperceivable, but a definite delay turning off as the capacitor discharges and keeps the relay fired. So obviously we got to start by dismantling the existing contraption that's in here, right? So, yeah, I got to remember how I did this. There's positive and negatives to doing things well. Positive, it lasts. Negative, it's hard to dismantle. This little circuit is done half well, but I gotta disconnect the wires going to it. Okay, I think it's all disconnected now. And coming out in pretty much one piece, a cutesy little relay, well, it's not very cutesy actually. It looks like a mutant from another world. That is a star ground, which is not dependent on that mounting point. We will be putting it back on there, and we got to keep track of what's what here, because let's just get reconnected. So that's going to be our signal wire from the back. This grounds out one of our circuits. That drives the MOSFET, which controls our indicator light, which is another thing. We haven't got an indicator light for the rhythm clip light, so we're going to be running a little bit blind unless I want to go popping another hole in here. But then that would kind of break the consistency here, because we have this as the indicator light. Whatever. So now I got to figure out how to mount this. And once again, I'm going to be using one of these little hobby boards. So this is going to be an overall better arrangement. I'm going to put it in and about the same area right here, pretty much. But we got to go pop some holes in this little board so that it's ready to install. Yes. I got holes in there now, kind of sloppy. That one's not quite center. That's fine. And you're just kind of hamming at this, right? Just kind of... Okay, confirm the tubes are out. Bring in a punch and a consultant. Oh, that one jumped. Should be good enough. Let's drill some holes. Nice. Bam, blammo. Burr, burr, burr. Chamfer and de burr. And it's always the other side that gets it the worst, right? At least I can get at it. That should do. Now let's mock mount this guy. Dun 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 dun. Couple half-inch 632 standoffs. They're your secret weapon. Gonna match that up with some 632 long boys coming in from the bottom. Hopefully these long boys are long enough. It'll be close, actually. I might need longer boys. Yeah, I don't think those screws are gonna be long enough. I'm gonna need slightly longer ones. That's okay, because I don't have the nuts in stock that I need. Now we can run these wires underneath here without much worry. And then this guy should slot on like pretty much blammo. Need to widen those holes a touch. Ta-da! Just put some nuts on that and we're good. Top. And we're gonna mark front. Now we have to fabricate on this guy. So the components we're using are these little tiny Panasonic TX2 relays. They are low level, they are signal grade switching. It says right here, you know, communications, DSL, home appliances, medical, audio, visual. They should be more ideal for this than your basic whatever electrical relay. Now these relays definitely have a positive and negative bias. After much head scratching, I came up with a layout. One side is positive side, one side is negative side. I'm gonna take one side of each DC leg to run this circuit. We can pull either or from center, which is going to be the foot switch. Now, if you can see this layout, it is, you know, a little bit tricky, detailed. Tried to stick with some nice symmetry, but we need to be able to control the MOSFET with the main switch. And so we're gonna have a negative common, and it's basically just gonna switch muting out between the two services. The first row is the common, the second row is normally closed, the third row is normally open. So the lead channel gets muted out, connected to this pole, the rhythm channel gets connected to this pole. Now we have the positive supply connected to here, so normally closed when the lead channel is running, because lead channel is going to be on by default. That's going to switch on that MOSFET, which triggers the indicator light. So that's going to connect right here. Meanwhile, I've bridged this together because this blue wire here connects to the rhythm circuit in such a way that, the rhythm clip switch is over here and then the ground point's over here. So these guys are going to be able to share a pole because this side here is going to be what turns the rhythm clip on and off. So we just have to pull another wire to get to the other side of this guy. Default is going to be rhythm clip on, by the way. I think I pretty much got this guy ready to install. It's so simple. 2 diodes, 2 capacitors. I maybe need voltage drop because I noticed these in testing consume just over 50 milliamps. They're rated for 40 something, but that should be within spec. It's just, you know, they're 3-volt relays and you're getting 3 point something off the chassis. So, well, let's see what we can do here. Over in this general neighborhood, we're gonna have to trim off some of these wires. Hopefully they're all long enough. This looks like it might not reach. It has to get into one of these holes here. Oof, I might need to draw a new wire from the other side. Or can I reroute this one to get just a little bit more slack? Maybe, if I fly it as in it's hovering over top, not along the bottom of the chassis. Not everything has to be stapled down to the chassis, you know? Yeah, it'll be manageable. Still have to trim it though, because these ends are just rough. This guy is short but sweet. Our blue wire, ground wire, signal ground that is. And we have to pull 2 more wires. We need to pull a wire for the other half of the switch, and we need to pull a wire that's going to go to the, so. And while I'm thinking about it, I don't think we're gonna have to attach anything. Might as well go ahead and fasten down our star ground there. So, those 2 blues just have to be jumped together. Doesn't matter in any particular, well, actually no. One's a ground side blue. You're gonna have to remember that. You know what? For that reason, I'll reverse the color code. I'll make white the signal and blue the switch. Yeah. All right, so our first connection, this little black wire here, lead master cut off, trying to get it through the hole, and it connects up here. Fusion. Then our common signal ground. Ooh, but our blue wire first. Figuring out what order to do these in is the tricky part. Our blue wire kind of goes just to this crossbar here, so too bad I soldered that crossbar completely down so I couldn't do a cleaner connection. That's the problem with hobby boarding. Sometimes, you know, as you're working on it, you're like, oh, I wish I did that a little bit differently before, or in a different order. Really clean up the look. Hopefully good signal gets through there. Okay, that is our standard switching circuit. Well, we got our signal wires hooked up anyway. Where's the one that's gonna fire it? This one. Oh, it's gonna get tricky because as I flip this down, the geometry of the cables is going to change. I might want to leave that one for after. Let's take a look at these guys coming in from over here. So we got to get a constant positive supply here and then output to the relay or MOSFET here, which is basically these 2 holes respectively. Oh, that went easier than I thought. Okay, can I trim in there? Secure that pin. Okay, relay's hooked up. Okay, MOSFET's hooked up. Now get the constant positive power connected. Trying to remember which pin it is. Oh boy, I smell burning. Okay, it's coming along nicely. Let's trim this, because I think that's gonna stay connected there, because I plan on having signal input coming on this side. All right, what's next? It's like a little nerve-wracking, like defusing a bomb. Oh, we haven't got anywhere near long enough a black wire for the negative supply of this. So I'm gonna have to pull another wire, quite possibly weave it into this other bank that we have going on here. That'll go nicely. Unslack it a bit. Okay, let's connect that to where the main negative for the other side's gonna be. Have I decided where that is? That's this little rail here. Oh yeah, it's gonna pop it in down over there. H, right there like that. All right, we got positive connected. What's next? MOSFET's hooked up. Grounding signals are hooked up. We need the drive signals. Those are the ones coming off the foot switch. I think they're gonna be wrapping around bottom. So I'm gonna connect this drive signal. That's gonna fire our main relay. So this thing should theoretically work now. At least the one half that was there already. Okay, we'll bring the white drive signal in now. Now we just have to get one last wire. It's getting a little tight in the general area where these guys go. I think that's it. I think I have all the connections on the board made. If I did this nice, this should all just kind of sit right here, just like that. All right, so I was at the hardware store and I got the hardware that I need. So we're gonna properly mount this pupper down. And that's gonna entail removing that mounting hardware that I already put in there. All right, now let's get these more nicer screws that I have. They're just solid 632 1-inch, stainless too. Ooh, mind you, I couldn't find stainless matching nuts to go with it. Oh boy, we need a different bit. Our bit is missing, sir. This is no good. Good thing I have other bit. That is the wrong screw. All right, now let's just give it the old reach around. Pair of pliers, just hold on to those. Snug them up. All right. So now we should be able to give this the slap down. Just like that. And then I see these in amps all the time. So I've decided to start using them myself. Do I have the right size on that? No. Need a size smaller. Yeah, I'll just snug those down. All right, I'm pretty sure that's not going anywhere now. So, once I get the rest of these wires connected, we have our positive, we have our negative, we have, oh, I got it connected on the other side. Well, let's do that now. While we're at it, need to make a bit of a modification to the lighting circuit. See, the lighting circuit has a problem in that I just blew a bulb because the 6 volts gets rectified a little bit higher than 6 volts, and it seems to have worn out the bulb real fast running on the DC. So we're gonna throttle that down a little bit. So we need to remove the grounds from here, or the negatives, I should say. You know, I have a hard time calling ground. It's not always ground. It's just a negative. But I guess, you know, people don't like negativity these days, right? Clips. Oh, that's a hole that's gonna have to be cleared out, bud. So those light bulbs were rated for 150 milliamps. 1 ohm resistor would drop that voltage 150 millivolts. So 9. Guess we'll have 7 volts. I'm thinking I'm gonna use that 6 ohm resistor that I didn't need for the other, you know, this should drop things by like 1 volt right here. If I got it cut so short though. Oh, I guess it'll reach over here. All right, now let's get the new negative wire in place. Oh, that's all that's left of my black wire. I'm gonna have to order more. So now the other problem is this MOSFET. A MOSFET, you gotta tell it what to do. You either gotta give it negative signal to tell it to turn off, or positive signal to tell it to turn on, in the case of this NPN N-channel MOSFET. If we do not tell it what to do, it's gonna float. And if it floats, it's gonna fry. Now the way it was on the old circuit, it got a negative signal through the relay itself telling it to turn off. Now it doesn't have that going for it anymore. The easiest way is to just put a resistor across the gate and source contacts. 10K, little tiny 10K. Just like what are these guys right here, sir? Just gotta kind of weave that in there now. You know, you'd think would be easy, but it's so small. I need tweezers. Yeah, I just kind of slopped that on there. Just like that, pretty much. I'll just tack it down. See, because the MOSFET switch is negative, it has a full negative connection here, or at least a proportional negative connection here. And then that's just bleeding negative over to the gate, telling it to turn off. But then when the relay kicks on over here and sends a full positive signal here, it's gonna overcome that negative signal because that 10K resistor will resist. So now that switching circuit should work fine. I need to find a replacement bulb though. I knew it. I have like one 6-volt amp bulb left in stock. Just one. I should place an order for more of those too. Get that jammed in there. Somewhere I have the jewel. Somewhere. It'll turn up. So, okay, we got power. We got our lighting back online. Now we just need to connect stuff over to the board and the jack. All right, so what do we have here? This black wire is the existing connection for the foot switch. And we got that button there, but well, that's got to come out now, right? And it sucks because it looks like I did a good job installing it. That's why I don't permanize stuff on my project amps. Oh yeah, that's hooked on there nice. Oh, my solder sucker is so worn out. I've sucked a lot of solder in my life. Come on. There. How about this other one? Okay. Now the wire, which is nicely wrapped on there. In a way that I should not have done, but I did. Right, that's off. Now we gotta install that, change that out with a TRS jack. Tip ring sleeve. So we can hook up both switches. Now, ideally, you would use, you know, one of the typical isolated type jacks. And what that will allow you to do is it has the 3 sets of fingers. So we could disconnect the manual switches when we have the foot switch plugged in. But that's not really important to do because you can always just unpress the switches so they don't interfere. And then boom, your foot switch is gonna work normally. Because that's kind of the purpose of the way I'm arranging this. I wanna have a chassis mount jack so it gets its ground signal. Oh, this thing's Japanese too. Maybe I want to find something cheaper. Oh, I got one of these. I forgot I have some of these in stock. These are switched jacks. They have like independent switching circuits. So there's our ground. That's tip. That's ring. And then these are switches. So the center and the lower are normally open until something inserts. Okay, let's see if I can get one of these in there. Well, I know I can get one of those in there. It's just a pain in the arse because there's all these little connections you have to make. Tip we want to be the main thing. Tack it on. Tack it on. Then the white, I come around and do the same thing except backwards. All right, now let's go ahead and disconnect on this switch that's on the board. We just have to remove this from this hole, no big deal. And the other side of the switch just seems to be tacked onto a crossbar here. No, it was in the hole. So the other blue wire I've got here needs to go into one of those holes. All right, where are we gonna tack you up, bud? Right here now? Right here? Gotta get it moist and inserted. Wow, eh? Sorry, children. Oh yeah, there you go. That'll turn on the rhythm clip. Rhythm clip's connected. Now it's just a case of getting everything connected to these jacks as they're supposed to be. Got the ground lug on the bottom of this thing because of how I positioned it. That's gonna be a pain in the arse. Okay, well, I'm gonna have to get some little bits of wire on there. We're gonna do a mid strip here. Oh yeah. It'll take and put this whole wire through the hole, and boom, just solder that on there, bud. I think we can sit this jack down. All right, now I just have to get the manual switches connected on there. There's a hole to put a ground wire. Oh, come on, just waggle into place, bud. Oh, I gotta get these old wires out of here. All right, those switches are grounded out. Now I just have to connect them to the jack, in which case this jumper is no longer adequate. This is the final connections, folks. Final connections, indeed. So, that to there, I guess. Guess we'll just use pieces of this wire that's already sitting here. We'll cut it exactly in half. All right. Oh, they're on the jack now. Now I just have to get them on the switch buttons. And one more, bud. Well, the hole's missing on this guy, so we just have to kind of tack her on there. There we go. We should be finished now. All right, I didn't do anything affecting the power supply or the main, so this thing should still be safe to plug in. Key term should. Oh, the jewel. Let's get that back into place there. All right, I got 2 lights. Uh-oh. All right, one relay's working properly. Oh, the other isn't. What the? Okay, well, let's take this opportunity real quick to test the voltage on the pilot light. 6.9 volts. I managed to bring it down a bit. What's the main output here? Yeah, see, 776. That's wearing on the light bulb. 6.92. I noticed the light bulb was running brighter after I did this mod. Okay, what did I do wrong on the switching circuit? I see what I did wrong here. If I'm right, I need to gently disconnect this right here. It should start working now. Let's see. Yeah, I put the flywheel diode on backwards by accident. Ah, silly mistake. Oh, these have a nice potent click to them. I should test how much current they're drawing. I kind of figured I might have to bias them and put some sort of current regulation on them. Because we're actively switching through the jack, testing the current's easy. You simply go to the jack here and find a bridging connection. And in milliamp mode, bridge it. 52. That's the same thing I found in testing. According to the data sheet, it's supposed to be 46.7. So we aren't particularly overdriving it. Let's test what voltage it's clocking in at. They're getting fed 3.6 volts. So they're 0.6 volts over. That should be within spec. Those relays should be fine like that. So let's fix on this flywheel diode and then I think we're done, bud. The hardest part of working on these hobby boards is when you have to take parts off of them. Not easy. Come on, buddy. I wonder if I can take that same one and just turn it around. Actually, with a little bit of creativity. Yeah, actually. I can get that lead to move down there. There's enough length on the leads. I just move that there. If I can get this one to come around or just over. I don't like having stuff go over, but... Okay, time to get burnt. Ow. We remap this lead down and around like that. Yes, we can. It's ugly, but it'll work. Apparently, you know, the induction releasing off a relay can be quite a bit higher. Like, I swear, when I was touching relays while turning them on and off, I felt like a shock hit my finger. Like, there's like no voltage there. Well, apparently there is, like a little Tesla coil. And it can cause the switch to arc out and wear out over time. All right, they're both working now. All right, let's slap it down and test it out, bud. Frick yeah. One of these days I ought to go through and cable manage this thing. There's just stuff everywhere. Well, let's get to this place. Test out, bud. Yep. All right, now that we have heaters firing, let's get corrected voltages. So 3.8, 3.8, 4 volts. I would expect that to have come down. Now, what's our lighting voltage now? Rectified voltage still 7.4 and lighting is 6.5. So that's good. Our light bulb's gonna survive a lot longer. We could actually maybe make that resistor value higher. 10 ohm? Should I go 10 ohm? I might actually go 10 ohm. I have 10 ohms. I was thinking of going 10 ohms for the relays over here. A little bit less voltage. Let's plug something into this. It is suspiciously quiet. I do not like this. It is too quiet. Oh, standby. So, main channel. Rhythm. Rhythm clip off. What am I playing? Well, that's only half the story. Let's plug a foot switch in there, make sure that works too, right, bud? I think you know it. Oh, yeah, I got a Marshall OEM branded foot switch made in Vietnam. So we just go ahead, we plug this pupper into there. Switches are disabled. Oh, channel works. I'm just kind of goofing off now. I'm not sure you know what you're looking at or if it even sounds good to you. But hey, it works. It works perfectly. Finally, Project Jubilee has a proper switching matrix. Yes, that is another something accomplished, and also we can switch on the rhythm clip, which I don't know why that's not a stock feature. Do the new versions have that? It doesn't make any sense that they wouldn't. But hey, I hope you enjoyed this. I like to mod on amps sometimes. Actually, I've been liking to mod them on a lot lately, so there's still some more videos like this coming. So stay tuned. Stay tuned. Stay tuned. And it is now late. Do I have time to do my red switch mod I wanted to do today? Ugh.